Stop.
Good morning. Can you hear me? Okay. All right. I'm texting here a little bit because we have a student who can't get access to the meeting. So we'll see if things work here in a second. I'm going to ask you a question. How did you get into the meeting?
Hi, good morning.
Morning. How did you get into the meeting?
So I went and on the syllabus, I clicked on the first page.
Yeah.
I clicked on the Zoom link that was on there, and then I copied the because once you do that, it'll say that the meeting ID is wrong, which it isn't. You just have to go and you have to copy the meeting ID that's underneath the Zoom link and put it into the box, and it'll let you in.
Okay.
Yep, that's what I did.
All right. Let's see here. Okay, let me try that one then.
Yeah, and then it says it's like a reoccurring meeting or something like that.
Okay. Sorry, bear with me here. So I'm getting bombarded with emails right now from students and techs saying that they can't get into the meeting. So give me 1 second here. The way that I got in just now was clicking on the Zoom link on the D2L site. Did that get anyone else in? Where it says Zoom link on the D2L site right under content.
No, I had to copy and paste the link as well.
Yes, Mary, I did
Yes.
it your way. I did it your way. And when I did that, I just had to use that digits that began with 951 and so on, and it went through.
Okay, so you just needed to use the Zoom meeting link number. Okay.
Yes, the way you did it, yes.
Okay, let me see if I can't find that Zoom meeting link number.
I have it written down if you really
Will
need
you
it.
tell it to me right now?
Yes. Okay,
Thank
are you ready?
Yes.
All right. 951 765
Okay,
two-
951 765.
25
Okay.
390.
All right, you know what? Give me 1 second. I'm going to share my screen with you. Give me 1 minute here. Because I think this will be faster than me trying to individually contact everyone who's contacting me right now. What was I doing? Oh, someone got in just now. That was email me. Let's see. Bear with me here. This is a new laptop to me, so I'm still figuring out some of it. I know I told it to compose. So you were saying that all you did was you copied and pasted. You copied and pasted the Zoom link in?
No, I actually, well, just the numbers. I pressed launch and then like just the numbers.
When you,
numbers that-
where do you get to, well, I'm sorry, where do you go to get into launch?
Okay, when that D is a DBL come thing up.
The D2L?
Yes, in there, you click on the syllabus link there, and then in there, you're gonna click it.
Okay.
On the first page of the syllabus,
Okay.
is where you can find the link, which I believe is what the other individual is also saying.
Okay.
It's there's two Zoom meeting links. The first one on the left side looks like it's for like your office hours.
Right. The one for the class. So
Yeah, the one for the class on the right-hand side of the page. If they just click that, and then the meeting ID is listed underneath, and all they have to do is copy and paste that into the box once they
Okay.
click the blue link, and that will, copying and pasting that meeting ID number will get them into this.
So do you see the email that I'm typing right now? You see it down here?
Mm-hmm.
So on the D2L site, click on the syllabus link for the class. It will bring up an option to launch.
I would say on the first page of the syllabus, click the,
Let's see here. Bear with me here. Click on the first page. Page of the syllabus. On the first page, let's say that. So click on the syllabus link for the Zoom meeting for the class on the first page.
yeah, it's a blue Zoom meeting link.
Blue. Zoom meeting link. So blue syllabus link for the Zoom meeting for the class on the, excuse me, on the, bear with me here, we're going to change this. On the first page. For the class.
And then I can actually read off the meeting ID that's listed on the syllabus, and you
It would-
can type that in.
It will bring up an option to launch. Bring up, I'll ask you for that in 1 second here. Bring up the option to launch the class. At that point, click, type in the meeting ID. Okay, what's that meeting? What's that meeting ID?
It is,
951.
yep, 951 765 2539
And at that point, what else? Is there anything else you have to do except maybe click return?
Nope, that's it. Once
Okay.
they put that in, then you can accept them into the class.
Okay. I don't know if you can hear my phone going off, but that's just students who can't get in. So just give me 1 second here. You should be able to enter the meeting at that point. Let's see what happens here. Honestly, if you take a lot of online courses, one of the first day is sometimes a little adventurous because students are just struggling to get into the meeting. So let's see. Why are you being difficult? It's not going to send a message. Let's try this. Okay, there it goes. Let's see if that works. So I'm going to start, and I may have to stall again just in case students, in case I get more emails and texts. But let's start and see what happens for a second here. Let me tell you one thing right first. If you would keep your camera on and let me see your faces while we have class, I would really appreciate it. I'm not going to make you do it. There are professors who will enforce that. I don't, because I know that I think there's privacy issues, especially when your camera is maybe your home or your office or something to that extent. But if you will do it, you will make my job a little easier, because normally in a face-to-face class, as professors, we can look at you when we're discussing things and tell whether or not you're completely lost, or if you're overwhelmed, or if you are understanding the material just from the way you look. And that doesn't work when your cameras are off. And so I would love to be able to see your faces, but I'm not going to enforce it with you. And I can see some of you have done it, because I will ask you frequently throughout the class. I'll say, do you understand? And a lot of people will nod in their camera, and then I'll know that you understand. And I really appreciate it, but don't feel like I'm going to make you do it either. See here. What can I say? Give me a second here. This is my second semester teaching AMP1 for HAC. I teach, I'm an adjunct, so I teach for 2 other schools. I teach for Carroll Community College in Maryland, and I teach for Stevenson University in Owings Mills, Maryland. At those two schools, I teach face-to-face right now, but at Hack, I'm teaching solely online. Every once in a while, since I'm sitting in my living room here, every once in a while, you will see my cats that will pop in and out of the photo camera. I have 3. I have, when my roommate is home, we had 2 dogs. We just ended up yesterday, my roommate traveled to Virginia to have one of our dogs put down. And so we're now down to just 1 dog, and she'll be back. My roommate will be back in next week, and we'll have 1 dog at that point. So three cats and 1 dog, all in one apartment, which tells you that we're pretty big animal people. Any questions about me? I sent you out a survey. I would like you to answer that. It came out, I think on, when did it come out? It went out on Sunday. I think those instructions are helping a lot of people get into the class. Go with me here. Let's get started with the syllabus. Oh, with that survey, if you go into the Dropbox on D2L, you'll see a place to load those in. If you click on it, it will ask you to load it. Before we even start, how many of you have been able to access the textbook? Is there anyone, and don't feel shy about this, is there anyone who hasn't been able to access the textbook, who has tried and it's not allowed them?
I have not.
Who is, tell me your name. Is it
Melanie.
Melanie?
Yeah.
Okay. Melanie, are you able to share your screen? Give me 1 second, as my phone is ringing and I know it's a student, so give me 1 moment here. I'm going to stop sharing. Melanie, do you know how to share your screen?
Yeah, but let me just go on to D2L.
Okay, give me 1 second. Hi. Hi.
I believe I'm looking for.
I'm Mary. You're looking for Mary. I'm sorry, I should have introduced myself. Yes, you're talking with Mary. Are you a student?
I am, and I actually just started. I
Okay.
know it was a little bit of a rush for me to get in. I was supposed to be on Zoom. I have been on Zoom. I don't know if I'm missing
You know what?
something.
Do me a favor. Do me a favor. So there's a link when you go into D2L. There's a link on the syllabus.
I had to physically type in the ID code.
Okay.
Okay, biology. Yeah, when I hit onto the Zoom link, it's actually taking me to where it says that it's an invalid meeting code. So
Okay.
then,
Does it give you an option to put in another meeting code? Can you highlight the meeting code and type in another meeting code?
yes, that's what I had found as far as the meeting code 976.
Okay, well, let me give you another one. Give me 1 moment, all right?
Okay, give me 1 second. Let me click out of this.
No, you're all right.
Join the meeting. Okay, yes, it's asking
Okay,
me
so
for
type in 951
951
765
765
25
25
390.
390. Okay.
And what is your name? Help me out here.
My name is Jade Phillips.
Jay?
Jade.
Jade, okay.
Yeah.
Jade, so type that in there and let me see when I'll tell you when you show up here on my screen to let you into the meeting.
Okay, it says open. I'm opening.
So 951 765 25390.
Okay, it says
All right, Jade, you're there. Give me 1 second, okay?
okay, thank you so much. I appreciate it.
Okay, are you coming in? Does it say you're joining?
Yes, I'm here now.
All right, perfect. Okay, I'm gonna hang up, okay?
Thank you. All right.
You're
bye.
welcome. Okay, one thing that you're probably already seeing with Zoom online class, if you're not taking more online classes, and I don't know how your other online classes work. For this one, if for some reason you can't get into the meeting, or having major technical difficulties, call me or text me and tell me. If it's happening to the whole entire class at the same time, I'm just going to get bombarded, and there's no way for me to pick them all up, especially if I'm trying to solve the problem at the same time. But you can still do it, and I will work to figure out the problem. But sometimes it's just one student, there's a technical difficulty, and I will try to give you ideas as to how to solve the problem. Where were we? So initially, Morgan, you were saying Melanie, you were saying that you couldn't get into the textbook. Can you
Yes,
share your screen?
yeah, I can. I was just confused on like where the link is to get the book. So, because it said on here that it will be on like D2L, but I
Well,
don't see the link.
let me show you. If you share your screen, I'll show you.
Yeah, okay, no problem.
Oh, I need to stop sharing mine. Okay, now, because Melanie, I know you're not the only one who's not sure where to find it. So that's why I'm asking you to share your screen. So go down to the first week 830. Now click on that first one, that external learning tool.
External learning tool, this
Yep,
one?
actually, if you go up that first one or this one, either one.
Oh.
Well, yep, that one worked too. So they're all going to take you to the same place. Go to that top one, that chapter 1, major themes of anatomy and physiology. Now click launch. Now click begin. Now it's going to ask you to set up your account. So it's going to ask you to reaffirm your email address. Give it a password that you can remember.
Mm-hmm.
So go ahead. I wouldn't give it a mobile number. Don't give it a mobile number. It's going to ask you, you have to do a security question. Now click continue. See what happens. Okay, so click confirm.
Okay.
So once you click that arrow over to the left, get you into the first assignment. Do me a favor right now though, before you click begin there, go down to the lower left-hand column, the lower left-hand side. See where it says select, go a little up, a little bit further up, about middle of the screen right there. Says
Uh-huh.
read.
This one?
Go down a little bit more. Read that one right there.
Mhm.
Click on that. This allows you to read the textbook.
Okay.
Now do me a favor, go back to the last page we were on, last tab we were on. Now go over to chapter 1 on the left-hand side. Go to chapter 1, scroll up a little bit right there, click that arrow that you've got your mouse over. Now click begin. This is a smart book assignment. For everyone, this is a smart book assignment.
Okay.
So with this assignment, what it is it's going to ask you, it says, do you want to learn more before you answer questions, or are you familiar with the material and ready to start the assignment? You can do it either way. You can start the questions, and then if you're not sure about the material, it will ask you again if you want to answer, to read a little bit. What this assignment is it's just encouraging you to read parts of the textbook.
I got a question.
Go.
I was in this already and I did start reading. And then last night I got a notification that I have zeros on like 10 assignments now.
What?
So I just want to let you know, because there was like a lot of things like
I told you had zeros on 10 assignments. Go ahead, Catherine.
chapters.
I think I got that same thing. And I hadn't started, I was reading, but I hadn't started answering any questions or doing
Right.
any of the assignments. And I saw that too, but I think it's just doing something weird as it's like setting up. Because
Okay,
I was confused by
sure.
that too.
Okay, why don't you, if you're finished that assignment, finish it. And if it still is telling you you have a zero for the assignment, let me know and let me figure out what's going on. No, that's a good question. I don't know what it's doing, but we'll work it out. So for every chapter that we cover in this class, you're going to have one smart book assignment. You're going to have one quiz, and you're going to have one chapter practice. Do the smart book assignment first. Do the chapter practice second. Do one attempt on the chapter practice second. And then do the quiz once we finish the chapter and lecture. And you'll have 2 weeks to take it, the quiz. The practice is unlimited attempts, and it will be open. I'm debating just leaving it open all semester long, because it will allow you to practice for your quiz and the lecture exams we have later. And allow you to know what material you're comfortable with regards to chapter 1 and what you're not comfortable with. Is that clear to everyone? Like, I'm getting some nods. Is it clear to everyone?
Yes.
Okay. Melanie, I'm going to ask you to stop sharing your screen.
Thank you.
Okay, you're welcome. And I'm gonna go into the syllabus here. So because there have been, I teach 3 sections for hack, and there have been some major issues this semester with people not being able to access the book. And so I reach out to someone else at hack. And from what I'm understanding about what he's doing to look into the problem is he reaches out to like 25 more people. And he tends to link me onto his emails, so I know what he's doing a little bit. And everyone is trying to figure out why students aren't being able to access the textbooks. You have already paid for the textbook. If you can't access it, I want to know. Don't pay for it again. You paid for it with your tuition. Don't repay for it. And I've had that happen a few times already this semester. So don't repay for it. You'll just make me feel bad. So if you can't get access to it, there is a possible 2-week trial, free trial. You can sign up for that. But first, just try to access it like we did with Melanie. And if that doesn't work, then I want you to email me or text me, tell me your name, tell me which class you're in, and then tell me you can't access the textbook. And what I do is I send your names to this person at Hack and let them try to figure out why you don't have access to the textbook. Is that clear?
Mhm.
So now let's go back and let's look at the syllabus here. So I'm not going to read through the whole syllabus because I know that you're more than capable of reading. So I'm going to read I'm going to skim through it a little bit and read what I think is most important to you right now, or what I think is most important. So I will fix this. I'm not sure what's wrong, but I'll fix the link. But my email address, mcgessel@hack.edu. My office hours, right after class is great, or Tuesday and Thursday from 2 to 3 p.m. My phone number is 952-201-3126. It's out of state. I'm a pretty new to the East Coast. I've been living here for about 3 years. That's a Minnesota number. I haven't lived there for about 10, 15 years. And I've moved a lot of different places, but I like to keep the same phone number. So I just hold on to that one. Feel free to call me and text me, email me first. Give me a couple hours to get back to you at least. I recognize that I do teach for 3 different schools. I teach 5 days a week. You're the last class I have of the week. But I do for instance, for example, I teach on Thursday night up until 6:30 at night, and it takes me about an hour to get home. And so you may not hear from me until after 8 o'clock at night if you text me on a Thursday night. However, I will work to get back to you. Other nights, another example, on Tuesday nights, I don't get home until a little after 10:30 at night. I will work to get back to you at that point also. Just be patient and recognize that I may not be able to get back to you immediately. If it's a critical thing, which very few things are critical. Let me explain, when I say that, very few things are critical. If you're struggling to get an exam in and it gives you a deadline of like an hour from now, and all of a sudden you're running into a glitch, realize I can give you a second attempt. If you run into a glitch, email me and tell me that there's a problem. And then recognize that I can give you another attempt, and that you don't, that you're not going to fail the exam because it's not working for you at that moment. So email me first. If you don't hear from me back within maybe, I would say 12 hours or even 6 hours or 8 hours, give me a call, or first text me and then call me. Let's see here. So now, of course, it goes too far now. So with this class, we will have 3 lecture exams. They will be worth 100 points each. They will be on that McGraw-Hill Connect. You will have 2 attempts to take each exam, and your highest score will be the one recorded. These exams are not cumulative. It will only test you on the material that we've covered since the last exam. So for the example, the first exam is set up so that it will test you over the first 3 chapters. In addition to lecture exams, those smart reading assignments, and I don't know if I finished explaining how those work, you will answer a series of questions. It doesn't matter if you get questions right or wrong. If you complete the assignment, you get 100%. If you don't complete the assignment, you get a 0. So it's not asking you it's not grading you on whether your answers are correct. It may give you more questions if your answers are incorrect, or ask you to read parts of the textbook. But you're graded on completion. The chapter practices are also on McGraw-Hill Connect. Almost all the work you do in this class, I'm pretty sure it's almost all of it, is through McGraw-Hill Connect. The chapter practices will consist of multiple choice, true and false, fill in the blank, and matching questions on McGraw-Hill Connect. These chapter practices are made so that you can do them an unlimited amount of times. They are really good study tools for learning for allowing you to identify what you know and what you don't know, and what you need to study. Some of the questions on these chapter practices you may see on a quiz or an exam later. What I do is I set it up so I give it a series of questions, and I tell it for each time that you attempt a chapter practice, I tell it to give you, for the first chapter practice, I tell it to give you 38 questions. And it's going to give you a random pool of 38 questions. The chapter, and so use those as a study tool. Remember, you can do them again and again and again, and your highest score will be the one recorded on the grade book. They're not timed, so you can use your textbook, you can use your lecture notes, you can use whatever you like. Your chapter quizzes for every chapter. So for every chapter, you'll have a smart book assignment, you'll have a chapter practice, and you'll have a chapter quiz. The quizzes are timed, and they will be very similar in format to the practices. They're going to include multiple choice, true and false, fill in the blank, matching. You'll have 2 attempts to take each quiz, and your highest score will be the one recorded. Class participation will involve attendance. For Zoom, it is mandatory that you attend. It's tightly linked to how well you're going to do in the class. And so I enforce attendance. I want you to be here. I may ask questions in class. I will, let's not say I may ask questions. I will ask questions in class. And I want you to be able to answer. And I want to encourage you to answer. Am I worried about you answering wrong in class? No. I just want you to answer. I want you to give me answers, and then I also know what we need to work on and it gives me some feedback also.
Can I ask a question, please?
Go ahead.
I seen as far as the textbook, how that is included. Now I also seen the dictionary. Is that something that's worth purchasing, or do you prefer for us not?
The dictionary, is it something you have to purchase, or
Yeah.
do you automatically have access to it?
No, it comes up that you have to purchase.
I probably wouldn't get it right now.
Okay.
You may decide later you want it.
Okay.
But I've honestly, that's the first time I've heard about that.
Yeah, because when I first set up, it does come up where the book is included, but then there's a dictionary that's underneath, and I think it's something where it's like the 11th, I think, like generation, if I'm not mistaken, but it comes up, it's like $36.99 or so, but it's the dictionary along with the textbook, but the textbook's included, the dictionary you have to pay for.
I wouldn't get it right.
Okay.
Yeah, I think the textbook is going to give you all the material you're going to need and more.
Okay. I just wanted to make sure. Yeah. I didn't know. Okay.
Good question. Yeah, I wouldn't worry about it.
Okay.
So class participation, I want you here. I may call on you, I may not. If we have breakout rooms, which I don't think we're going to have a lot of those, being that I don't have you for lab. However, if we do breakout rooms, I want you to be involved. We have a final exam. It's going to be cumulative. So it's going to cover all 10 chapters or all the chapters we get through in lecture. And it will follow the same format as the exams, in that you will have 2 attempts to take it. It'll be timed, and it will be worth 150 points. So let me reiterate, for each chapter, we have 1 quiz, 1 smart book assignment, 1 chapter practice. Are there any questions so far? And for one more thing, let me just repeat this. For every chapter quiz and every exam, you have 2 attempts to take it. And your highest score will be the one recorded. Now, actually, let me say one more thing about quizzes and exams. Are you allowed to use your book? What would you say? Are you allowed to use your notes? Now, my question for you is, if I tell you that you're not allowed to use your book, you're not allowed to use your notes, you're not allowed to use your friends, how do I enforce that? I don't know how I would enforce that, except sit here and watch you while you take it. And I'm not going to do that. So I say yes to all of those. However, recognize that it is still timed. So you will not have time to look up all the answers. You want to study the material beforehand. But I'm not going to prevent you from using notes. I'm not going to prevent you from using the book. I'm not going to tell you not to use them. Because if I say that, there's a possibility that someone in the class will use it. And it could possibly put everyone else at a disadvantage. And I'm not going to do that. So use whatever you have at your access. But recognize that it's also timed. Moving forward a little bit here. So attendance is mandatory. I'm guessing, have you already had lab this week? Have you had lab yet? Or is that today? Is it today? Okay. I'm getting a nod. Okay, it's today. All right. I know, I'm guessing that for Dr. Weeks, it's also mandatory. If you know that you're in need of accommodations, please contact Erin Rose. Are there any questions so far? Any other questions? So today, I want to start the first chapter. We may finish it, we may not, but I want to start it. And then we'll do the second chapter and the third chapter and so forth. Like I said before, email me, text me, call me. let me know what's going on. If for some reason, when I say attendance is mandatory, I do recognize that we are going to have technological difficulties at times. Tell me when you're not able to attend. Tell me when there's technological difficulties. Contact me and let me know what's going on. And believe me, I'll understand. As far as I know, and my roommate's not here, so she can't say it, but I'm a fairly nice person. As far as I know, I've never intentionally bit or hit anybody. So let me know when there's a problem. And I will do what I can to help you. This job as a professor my job is to get you through this class. That's my job. But it does go 50-50. If you're struggling, I need to know about it. And I will do everything I can to help you. But you also need to communicate with me the best you can and let me know when there's a problem. I'm going to give you now, before I forget, I'm going to give you some phone numbers. So the first phone number I'm going to give you is, sorry, I have to check my phone to get these phone numbers. So give me one moment here. First one is the Hack IT Technical Support Line. And their phone number is 717-780-2570. Oh, and of course, I'm not typing it all. Give me 1 second here. 717-780-2570. The second phone number, so the first one, that 717, is the Hack IT Technical Support. The second phone number is the McGraw-Hill Technical Support. And their phone number is 1-800-338-3987. If you are having problems with McGraw-Hill Technical Support, contact me and tell me you're having problems, especially if it's during a quiz or an exam. Next thing, call them, because they can help you troubleshoot your computer. I am not really great with computers. I'm fairly good in that I'm learning as I go, and I can troubleshoot a little bit. But I usually call someone else when I have a major computer problem. My dad is usually my computer go-to person. And so I will not probably be able to computer shoot and figure out what the problem is on your computer. That's why you want to call these other 2 phone calls. I will tell you, if for some reason you pick it, you're opening the you're opening the smart book assignment and the book won't come up, chances are that's a pop-up blocker that's set on your computer that's preventing your book from opening. I don't know how to disable a pop-up blocker, but I know it probably is a pop-up blocker. The people at McGraw-Hill can tell you to try disable and show you how to disable a pop-up blocker. So give them a call first. Let's see. Trying to make sure I hit all the important things. Coming into content. First week. So the first thing at the very top, that's the smart book assignment. You click on that, it will take you into McGraw-Hill Connect. The second one is a PowerPoint for this chapter that I've set up. The third one is a study guide. And you're gonna look at this. It's not a worksheet. I don't want you to turn it into me. It's just a study guide. And it will tell you what you are going to be asked to define for chapter 1. It's going to ask you it's going to ask you questions that I'm going to want you to know by the end of this chapter. 95 to 99% of this we're going to go through in lecture. If you can fill this out, you should be ready for an exam. I will have one of these for every chapter. So as we go through lecture, be working on that study guide. I would read through it before you come to class. And when we start hitting the different topics, you can work on filling it out. Here's the chapter 1 practice. I'm going to set this up. I want to give it a due date. Yeah, I'm going to give it a due date. But that's also in McGraw-Hill. Remember, you can do it over and over again. And your highest score will be the one recorded. And here's the chapter 1 quiz. Are there any questions about what will be expected from you for every chapter? I'm just trying to think if there's anything else that I think we should cover right now before we jump into this. Let's just jump in at this point.
So just a quick question, the quiz is due. The practice is due in October, but the quiz is due in September?
The quiz, so the practice you can do over and over again.
Okay, but,
Up until the first exam. That's why it's open for that long.
okay,
Let me show you that one thing really quick with that, talking about that. Actually. So yeah, the practice is due
October 4th.
officially on and that's the first day, I think, of the exam, or of the first exam being open. If you look right here, so this is on, I think, the course home page. It gives you the due dates for everything on McGraw-Hill.
Okay.
I'm going to expand out that quiz, that chapter 1 quiz, because I'm not sure if we'll finish it today. But what I want, the plan is that when we finish one chapter and lecture, from that day, you have a week to get the quiz done. So we will finish, we will most likely not finish it today. We'll finish it next Friday. And then from next Friday, you will have until the following Thursday at midnight to take it. Is that clear? And I will adjust that due date. I'll adjust it right after class today, so that you know right now that you have approximately 2 weeks to take it. I would wait, and if it was me taking it, I would wait until we're done with it, talking about it in lecture. You'll see I'm constantly looking down at my phone, because when it vibrates here, I've turned off the sound, but when it vibrates, I want to make sure it's not a student. And so bear with me if I keep looking down off to my side, that's what I'm doing. Especially, I'm more worried that it's a student in this class. So bear with me as I do that. So major themes of anatomy and physiology. Anatomy is the study of structures and the relationships among the structures. The first studies used dissections. Our most recent studies use a lot of imaging techniques. We still do a lot of dissections. However, dissections tend to not work on living people and living things. And only imaging techniques tend to keep people alive as we look at structures. Therefore, we tend to focus a lot on imaging techniques. I'm a big fan of dissections. I like doing dissections. but it doesn't work so well if you start cutting through material. Well, you may want to see what that material looks. You pull out a muscle, but you want to know what it does and how it looks before you tore into the hand. So that's why we like imaging techniques. Physiology is the study of how body structures function. Complementarity is when a function relies on an object structure. Structure dictates function. And if we change an object structure, we change its function. I have a balloon back here, and I don't know if this is going to work very well. But when we look at the heart, for example, the heart is like a major longitudinal muscle that wraps around the atria and wraps kind of in this little V-like shape around the ventricles. When a muscle contracts, does it shorten or lengthen? When a muscle contracts, does it shorten or lengthen?
Shorten.
It shortens.
Right.
So this muscle, this really long muscle that wraps around the heart here, when it shortens, what is it going to do to the volume within the heart?
Shrink it.
It's going to shrink. What's going to happen to all the blood that's in the heart when the heart shrinks?
Get forced out.
It gets forced out. So the structure of the heart, the fact that the muscle wraps around the heart in the way it does, allows the heart to be an effective pump when the muscle contracts. What if the muscle isn't wrapped, or, for example, what if someone's born with a birth defect that makes it so this muscle doesn't work as a big, long muscle that wraps around it? That person's heart is not going to work as effectively, right?
Right.
So heart structure dictates function. Function dictates structure. No, let me say this. Structure dictates function. If I change the structure, I change the function. If part of that heart muscle dies, for example, in a myocardial infarction, all of a sudden the heart doesn't work as effectively as it should as a pump, because there's some slack along that long muscle that is no longer going to be able to contract effectively. And you'll learn next semester, heart muscle is not replaceable. So once it gets ischemic or hypoxic and dies, it's not replaceable. So we like to know about structures, really like to know about structures, because we want to know how those structures function. So there's a series of techniques that we as humans have developed to look at body structures without having to perform dissections. And this has greatly accelerated the health sciences. The first technique that we're going to look at is X-rays. X-rays are high frequency, high wavelengths, high frequency wavelengths that are absorbed by some structures in the body and not absorbed by others. The harder structures tend to absorb them, like our bones, like some of our muscle. Some of our tendons and ligaments will be able to absorb X-rays. However, tissues like our lungs will not be able to absorb those X-rays. So when someone gets an X-ray taken, they lay down on a photographic film and we direct a bunch of X-rays at whatever part of the body we want to be able to X-ray. And on the film underneath that person or underneath the object we're looking at, whatever part of the body that does not absorb the X-rays will come out looking black on the photographic film. Whatever structures absorb the X-rays will come out looking white on the film, producing a negative, photographic negative. So X-rays are really good at visualizing, bear with me, visualizing structures that absorb X-rays.
My feet are cold.
You know what, because we've been sitting since about 8:30, let's take 10 minutes. Why don't you get up and move around? I'm going to get up and move around, and let's come back in 10 minutes. So we'll come back around 10 o'clock. Okay, let's get started again. So X-rays, when they are absorbed into tissues, it appears white on the film. They work really well for being able to visualize harder tissues that are absorbed. Harder tissues that absorb X-rays. However, for softer tissues, they don't work very well because they are just not absorbed. Hollow organs and blood vessels can be visualized using what's called a digital subtraction method. Oh, bear with me. Digital subtraction method, or digital subtraction angiography. Angio means blood vessel. What does graphy mean? If you break up that word, what does graphy mean?
Picture.
A picture. So angio means blood vessel. Graphy means picture. So it's taking a picture of the vessel. So when with this method, they inject a heavy metal solution into the vessel. Let me put it a different way. They inject a dark contrasting medium. It fills the structure. Blood vessels and intestinal tract fills the structure. And the result is that when you subtract out the background, you get a clear picture of the structure that can be studied independent of the rest of the body. For example, in this first picture, this is the aorta. Heart about right there where you've subtracted out the heart, and you're just looking at the aorta and the branches coming off the aorta. The brachiocephalic and the left common carotid and the left subclavian. Down here, we're looking at the right common carotid. Another technique is often used is sonography or an ultrasound. It's the second oldest and most widely used method of imaging. Mechanics involve a handheld device that is pressed against the skin that produces high frequency sound waves. Sound waves echo back against the surface of internal organs. And the echoing pattern, from the echoing pattern, a picture is formed. Benefits of this is that we're not using harmful X-rays. Often used to view tissues in motion. CT scans or computed tomography is a modified X-ray that can be used for detecting things like tumors, aneurysms. Aneurysm being a weakness in the blood vessel wall. Cerebral hemorrhages and kidney stones. It's formerly called a CAT scan. It's a modified X-ray tube in that people are placed within, or objects are placed within the center of a spinning tube. In this spinning tube, there is a X-ray tube that rotates around the individual with a detector or a photographic film on the opposite side. This involves low intensity X-rays and computer analysis. It produces very, very, very nice 3D cross sections. Benefits to it, it increases the sharpness of images compared to your traditional X-ray. One disadvantage to it is that it takes longer. And the individual has to stay very, very still and not move. And if you can imagine, I've never had a CT scan taken. Actually, you know what? I did have one taken at one point. But at that point, I was actually recovering from a really nasty car accident. And I can honestly say I don't remember a whole lot about it. But from what I've heard from other people, it can be a little traumatic. They stick you in the tube, they tell you you can't move.
Yeah.
And there's a lot of noise involved from what I've been told. However, it produces very, very, very nice images. I think, Becky, have you had it done before?
Yeah, I had one of my back.
Okay.
I was 18 and it was car accident and it was not pleasant.
Really?
Yeah, because I remember laying there with my hands on my chest and I had to take a deep breath and then my hands hit the top and then it just, yeah, it's not pleasant.
Oh, I can't imagine. I know with children, when they do CT scans, they'll put them under.
Yeah, that would make sense.
MRIs are better than CT scans for visualizing softer tissues, like the brain and the spinal cord that's enclosed within the skull and the vertebral column and the knee joint. MRI stands for magnetic resonance imaging. The mechanics involve alignment and realignment of hydrogen atoms within a magnetic field. So during this image, a magnetic field is implemented. You induce a magnetic field which aligns the hydrogen atoms. What, for any of you who have had a basic chemistry course, and we'll talk about this next, I think in the next chapter, what molecule do you know of that we tend to have a lot of, and it contains a lot of hydrogen? And it's fairly small.
I'm going to say water, but that's...
I would say water too. Let's go with water. So water in tissues that contain a lot of water, we induce a magnetic field which forces the hydrogen atoms of the water to align. That's what creates the images in magnetic resonance imaging. In tissues where there's not a lot of water, like bone has relatively less water, MRIs are not very good at taking pictures. That's the reason that we can take a picture of we can use an MRI to take a picture of a brain without opening the skull. Because the MRI will look right through the brain and look specifically at the brain. See me, it will look right through the skull, it will go right through the skull and be able to, and we can visualize the brain. Here we're looking at a knee joint. Here's the x-rays. Here's the MRI. I'm guessing what they're looking at there might be a torn meniscus or some sort of bursa or some sort of inflammation. A PET scan or positron emission tomography scan can be used to assess the metabolic state of a tissue. For example, after a heart attack or with a cancer. What this does is we introduce a radioactively labeled glucose tracer. And we measure the amount of radiation that is being emitted as that radioactively labeled glucose is being broken down. The parts of the body, therefore, with the scan, the parts of the body that are the most metabolically active at that moment are going to light up with the highest amounts of radiation. So this is very good for being able to detect tumors actively metabolizing tissues. In this, for example, in this scan right here, what they're looking at, the normal brain normal brain, the little red here is a substantia nigra. It is the part of the brain that's involved in controlling involuntary movement. In a brain with Parkinson's disease, the substantia nigra's functions are greatly diminished. It's the reason it lights up really well in a normal brain, and the amount of metabolic activity in a brain with Parkinson's is decreased, diminishes. Now, here's some questions for you. What structures are better seen by an MRI than an X-ray?
The joints.
The joints, and why?
Like the tissue for the
Yep,
tissue.
the tissue. Why is that the case? What makes an MRI significantly different from an X-ray?
Because the MRI visualizes the soft tissue better, and an X-ray focuses more on hard joints like bones and stuff like that.
Things that tend to absorb the X-rays really well.
Right.
What structures are better seen by an X-ray than by a PET scan?
The dense tissue, I believe.
Yeah, most tissues the better structures that are absorbed by an X-ray are those that actually absorb the X-rays. So structures that have significantly more metabolic activity are better absorbed with a PET scan. Not to say that bones are not metabolically active, because we'll talk about bones here in a few weeks, and we'll learn that they're anything, let's say, how do I say this? They are more active than you realize when it comes to them being remodeling. They undergo it all the time. Ellen is pregnant and tells Janet, one of her coworkers, that she is scheduled to get a fetal sonogram. Janet expresses alarm and warns Ellen about the danger of exposing a fetus to X-rays. Is Janet's concern warranted?
No.
Why?
Because it uses sound waves, not X-rays.
Right. I like to think, one thing that I like when I think of an ultrasound is I think about a bat and how they put out high frequency sound waves and they detect mice based on the echoing pattern. Same way an ultrasound works. So we talked about this a little bit before we started talking about the way we visualize structures. But the structure of a party allows for the performance of specific functions. For example, the bones of the skull provide protection for the brain, and thin air sacs of the lungs permit the movement of gases like oxygen and carbon dioxide. So the hard bones in the skull protect the softer tissues of the brain. The thin sacs of the lungs allow for efficient diffusion of movement of gases. If for some reason the bones of the skull become softer, or bones become softer overall, they lose their function. If for some reason the air sacs in the lungs become thicker, or there becomes less, more impeding of the movement of the gases because the sacs become thicker, all of a sudden the movement of the gases becomes less efficient. If you think about someone who's struggling with pneumonia, or let me think about another, SRV, RSV, respiratory severe virus. I think that's how it's said, where the air sacs become inflamed. What other examples of complementarity can you think of?
Would skin be one?
Why? What do you mean? Can you describe why you think skin would be one?
I don't know. I just would think that it's protecting everything inside, and if it breaks down, then it could cause issues.
Right. What would it cause? Give me an
Infection.
idea. Infection.
Yeah.
Also water loss. one of the major concern, the first major concern when someone gets burned is dehydration. Because the skin contains what's called keratin. You'll
Right.
talk about this in lab, I think, later in a few weeks here. The skin contains what's called keratin, which is a water-resistant, oily, hard substance. And when that gets destroyed with a burn, the first major concern of a whole body systemic burn is dehydration and then infection. So you're right. Any other examples? There's many ways that we can assess certain aspects of a body structure and function. First one is inspection, looking at a body's appearance. For example, the presence of a rash. Palpitation, gently touching the body surfaces with hands, looking at the pulse rate and pulse and the heart rate determination. I'll show you a palpitation. And when you meet with Dr. Weeks, is that how you pronounce his name? Do you know? Dr. Weeks, your lab instructor. Is that how you pronounce his name? All right. Well, when you meet with him, don't tell him that I'm teaching you about this. But if you right here, I'm gonna stop sharing my screen for 1 second here. So if you stick your finger, so here's your manubrium right here, the top of your sternum. If you stick your fingers right down here, and you got to press fairly hard, so don't do it on someone else, just do it on yourself. But press fairly hard right underneath your manubrium, and then stop talking for a moment. Do you feel a pulse? You got to press fairly hard down there. Do you feel a pulse? Someone nod when they feel a pulse. Got to press fairly hard, Becky. The reason you feel a pulse right there is your aorta is right underneath there. I don't know just how far it is down there, but I'm guessing it's probably about an inch or two. So when we talk about palpitation, don't do that on someone else. But I think that's kind of a neat way of being able to feel a pulse, but just do it on yourself. So palpitation, gently touching body surfaces with the hands to measure the pulse rate and the heart rate determination. Auscultation or auscultation. Listening to body sounds to evaluate the functioning of certain organs. Listening to the heart and lungs using a stethoscope. You can also do it for stomach sounds. Percussion, tapping on the body surface with fingertips and listening to the resulting echo. We can also look at different aspects of body structure and function through cadaver dissection. cutting and separating human body tissues to reveal tissue relationships. We can also assess body structure and function through comparative anatomy, studying multiple species to learn about form, function, and evolution. So I'm specifically using these two figures over here because this is a human heart. And this is the heart of an earthworm, where it says it's considered that they have 5 parts to their heart. And each one, and what I think, and I'm not no comparative anatomist, something I haven't had a lot of study with. But what I think it is it's a spiral. So in the earthworm, the heart is kind of like a spiral muscle that contracts. Another interesting example of comparative anatomy. I went down to my brother's house. He lives in Richmond, Virginia, approximately. And I went to his house this summer and I had kind of a science day with his kids. And we bought some preserved frogs and we were dissecting these frogs. And I kept looking for a trachea because I honestly, the last time that I dissected a frog, I think I was in high school. And so I was trying to find a trachea and couldn't figure out why I couldn't find a trachea, an air pipe that's right here in these frogs. And my sister-in-law Googled it and found out that because frogs don't have a neck, they don't have a trachea. And so I was like, well, all right, I learned something. There's no trachea in frogs. Another way that we, and in more severe cases, we can do exploratory surgery through opening the body and taking a look inside to see what's wrong and what can be done about it. Usually, most often, they use medical imaging and then do surgery. But they only, and oftentimes that works best unless they can't see what's wrong using medical imaging. So medical imaging, viewing the inside of the body without surgery. Radiology is specifically that branch of medicine concerned with imaging. Gross anatomy, so using a lot of cadaver dissection to study structures that can be seen with the naked eye. Histology, using examining tissues with via a microscope. So histology is the study of tissues. Histopathology is studying tissues for signs of disease. In this example that is shown here, have a typical blood smear. You can see 2 leukocytes in there, 2 white blood cells. However, in leukemia, you see a lot more white blood cells, and a lot of them are immature. Cytology is the study of structure and functioning of cells. ultrastructure, viewing the detail of cells and tissues via an electron microscope. Name the method, excuse me, name the method that would be used, or really? I'm sorry, give me 1 second. I am using a new laptop. I'm getting more familiar with it every day. But name the method that would be used for each of the following. For listening to a patient for a heart murmur.
Oscillation.
Oscillation. What about studying the microscopic structure of the liver? Somebody else besides Becky.
Histopathology.
Or let's use histology for this one. And
Okay.
Catherine, what about the second one? Microscopically examining the liver tissue for signs of hepatitis, which is an inflammation of the liver. That would be your first answer, your histopathology.
Yeah, for it to be underneath the microscope, it would have to be, histopathology.
Learning the blood vessels of a cadaver.
Would that be like gross?
It's gross anatomy / cadaver dissection.
Mhm.
Performing a breast self-examination.
Percussion? Is it percussion? Like 'cause
Percussion.
you're-
I would use percussion.
yeah, 'cause you're
What else? Palpitation.
palpitating. Yeah, that's
So within the body and for the synthesis or the building of the structures of a human body or any organismal body, there is a hierarchy of complexity with emerging properties. What this means is that when it comes right down to it, our body consists of atoms, of elements, chemical elements. These atoms bind to one another and interact and react with one another to form molecules. Molecules react with one another to form macromolecules that then ultimately will become organelles. Organelles, let me give you an example. Mitochondria, nucleus of a cell, the chloroplast of plants. Organelles interact and function and integrate one another to become cells. Cells become grouped together to form tissues. Different tissues grouped together to form organs. Organs grouped together to form organ systems that carry out specific functions. So for example, your stomach has a specific function in the digestive system. Can it carry out all of digestion by itself? No. However, when we connect the stomach up with the small intestines, Now we allow that food to be broken down or macerated a little bit and then absorbed in the small intestines. So organs come together to form organ systems that have specific functions. Organ systems come together to form organisms. So at each step along this hierarchy of complexity, there are properties that emerge that aren't there in the lower levels. So for example, atoms, when they come by themselves, they have some function. They do have a function. They react with one another, but by themselves, that's all they are, is reactive little balls. However, when they react with another ball and bond, now they're capable of a function that they didn't have before. And it goes up until organ systems then are interacting with one another to perform the function of producing a whole organism and allowing survival and life of a whole organism. One thing to remember here is that cells are the smallest basic units of an organism that can carry out all the basic functions of life, which we'll talk about in a little bit. So here's a simple description of an interrelationship among organ systems. Oh, that's not what I meant to do. Sorry. So the digestive system takes in food. Food is absorbed in the small intestines into the cardiovascular system. Cardiovascular system is integrated and interrelates with the digestive system. However, it also interrelates with the respiratory system. So the cardiovascular system with the respiratory system allows for the taking up of oxygen and the release of carbon dioxide into the environment. The cardiovascular system also relates with the urinary system to eliminate waste. Throughout the body, the cardiovascular system also is integrated with individual cells to allow for the absorption and the uptake of nutrients and the elimination of waste. So the lungs by themselves are really good at allowing the blood to absorb oxygen and eliminate carbon dioxide. However, without the cardiovascular system, the life of a whole organism is not possible. So when the two systems come together, that's where we get the emergent property of being able to circulate oxygen and eliminate carbon dioxide. Any questions? And one thing that the integumentary system does, I think Becky made this comment about complementarity of the skin. Integumentary meaning the skin and the nails and the hair. The integumentary system protects these other systems so that they can continue to function. Which of these is the correct representation of the hierarchy of biological complexity from least to most complex? Which one, A, B, or C?
Would it be C?
I think it would be C. So molecule, intestinal cell organelle, intestinal cell, intestinal tissue, digestive system, and organism. Atoms and molecules are part of which level of organization in the human body? R.
B, cellular.
I would say chemical.
Oh,
I would say chemical for this one.
Is it because they're like creating the reactions
Correct.
that are needed for the next like
Yes.
level?
Yes. A structure made up of two or more types of tissues that performs a specific set of functions is at what level of organization?
Organ.
I would say you're right, Braden. I would say it's the organ. One thing that I'm going to show you here, and I know they often use these to describe physiology, is function concept maps. If I can get it and not have it shift around on me. So body systems, endocrine, nervous, integumentary. Body system that's associated with bones and support, the skeletal. Skeletal system includes bones and cartilage and ligaments and tendons. More tendons and cartilage. Functions and support and protection and locomotion. Muscular system functions in posture, locomotion. Urinary system includes the bladder and the kidneys. Urinary filters blood from the blood vessels. Circulatory system functions in circulating the blood eliminating waste, carbon dioxide. See that bottom part? Maybe. So I apologize. Let me go back down. Oh, sorry. Digestive system breaks down food sources, molecules, substances that can be absorbed into the blood vessels. The reproductive system includes the ovaries and the testes in males, ovaries in females. So showing how each of these body systems are interrelated and allow for emerging properties. One thing that we have when we start studying body structures is we find out that there's some anatomical variation. No two humans are exactly alike. Anatomy books show the most common organization of structures. However, some people lack certain muscles. Some people may have an atypical number of vertebrae. Some people have seven, most people have 7 vertebrae. Some people may have 6. Some people have an atypical number of organs, like kidneys. Some people may show what's called situs inversus, situs inversus, which means that there is a left-right reversal of organ placement, meaning your heart's on the right side of your body. Your stomach's on the right side of your body. Go ahead.
Oh, I'm sorry.
No, please, go ahead.
In most cases, are these things considered just kind of like evolutionary traits? Like, you know, everybody's a little bit different. So would some of those things most of the time just be like an evolutionary thing?
It
or
might
would
be.
it be more so like a birth defect?
It might be, but you know, I would say let's not call it, unless it's detrimental, we won't call it a birth defect.
Right. Okay.
But it might be. You don't know what might be advantageous to not having something that other people have. I'll tell you, I have a really good friend. At least I had a good friend. I told you I'm new to the East Coast. I moved here from Idaho. I had a friend in Idaho whose daughter was born without any asymmetry of her organs. And what that meant is that her heart was in the middle of her chest. Her liver was in around the middle of her body, rather than having it be on the right side of her body. It's now in the middle. She was born without a spleen, because the spleen only shows up on the left side of the body. See, and she was born without a spleen. When they saw this in the ultrasounds, they were pretty worried, because it just didn't, it looked like her heart had two lefts of a heart and not a right and a left side of her heart. They were pretty worried. So closest biggest children's hospital to where I was living in Idaho is Primary Children's in Salt Lake. So they scheduled her delivery and told her parents to prepare themselves. She came out and she's actually normal. Her older sister's in the 90th percentile for was in the 90th percentile for birth and weight and development. The little girl born with no asymmetry was also in the 90th percentile. They thought that she would require immediate heart surgery right after birth. She ended up not needing immediate heart surgery right after birth. And she, as far as I know, has continued to move forward with her life. And she's probably now about 5 or 6, 7 years old. Her plumbing, when I talk about her plumbing, meaning her blood vessels, her aorta, that should come off and loop off to the left and come down, doesn't do that because she lacks the asymmetry.
Mm-hmm.
But her plumbing functions the way to keep her alive, just the way yours and mine does. So even though it's kind of arranged really weirdly, she is perfectly healthy right now. I don't know.
Yeah.
We just accept when we're working in the healthcare field, or when you're working in the healthcare field, that everyone has some anatomical variation. It's really fun when you go into a dissected cadaver and find out that they lack certain things.
Yeah, absolutely. And that's kind of why I asked, because sometimes people will live their entire lives and don't even know that they're missing something or have like an extra of something.
Right.
I know that, I mean, my cousin has like an extra bone in her foot that she didn't even know she had until she was playing tennis and she had something happen and she had to like go to a doctor for it. So yeah, those things, that's kind of why I asked, because those things are actually pretty common.
Yes.
Even with like wisdom teeth, like I work in a dental office, and I mean, I think it's more of like a genetic thing, but everybody's different. Like some people don't get their wisdom teeth at all. Some
Right.
people have all 4 of their wisdom teeth. And then sometimes I have patients that only have like 1 or 2 wisdom teeth. So, but none of it's abnormal.
Yeah.
It's
And if
the
you
way
think
it is.
about it, wisdom teeth are not really a benefit to us.
Yeah, not anymore. Yeah.
Well, yeah, because and I think, I wonder if we even talk about it in here. I can't remember. But if you think the only reason we don't have the same jaw width that apes do and so forth. And so that's why they just get in the way. They're not very beneficial to us. And so, yeah, good question. So like Catherine was saying, some anatomical variation. Variations in the kidney shape. Variations in the vessels coming off the aorta. There are basic life functions that distinguish all living organisms from non-living organisms. There's hierarchy of complexity. That's the first one. If you think about a rock, they don't really have the hierarchy of complexity. Cellular composition, all basic life is formed from cells. As far as I know, a rock doesn't have a lot of cells. Can't say I'm a really big geologist, but rocks don't have a lot of cells. Metabolism, being able to take in food sources and break down and absorb and eliminate waste. Being able to respond to stimuli. Movement. Homeostasis, which is something we'll touch on today, and we'll go. Let's see, when did we get out? We get out at 11:10. We'll touch on maybe a little bit today, and we'll really go into it next time. Homeostasis, being able to maintain physically tolerant limits. Development, being able to form differentiation of cells into specialized cell functions and growth. Reproduction and the evolution, like Catherine was talking about. Being able to evolve. People not having all 4 wisdom teeth, because it's not like it's ever been a big benefit to us. So life as a whole is not a single property, but a collection of properties. Cells, I'm sorry, bear with me. Cells are able to transport materials from one region of the cell to another, just as the body is able to transport substances to different locations. Or skeletal muscles working with your skeleton can transport you from the sofa to the refrigerator. What basic life process is illustrated by this description?
Movement.
Movement, correct. So we will talk about a little bit about homeostasis here. First, before I keep going, and I would really like you to just be open with me. If you have questions, say, Professor Gessel, I have a question. Feel free to stop me if you're not sure, or if you want to discuss something in more detail. Are there any questions right now, though? Homeostasis is the ability to detect change, activate mechanisms that oppose it, and therefore maintain relatively stable internal conditions within limited boundaries, tight boundaries. Feedback mechanisms can alter the original changes that triggered the change in homeostasis. And these are called feedback loops. Let me give you a good example. I don't have any children. I can tell you I have a cat. And Leo, you're going to come up and introduce yourself. Come here, buddy. he says he hates having to introduce himself. But this is Leo, and he's my 14-year-old little firecracker. We'll talk about him a little bit later in the chapter, but he's had his adventures in life. He is obedient for the most part. He's pretty loyal to me. Not so loyal to my mother, who's my roommate. But he will do things that I tell him not to do. And I've also learned not to swat him because he swats back. But he does something I don't want him to do. And I'm like, Leo, no. And most of the time he just looks back at me like, I don't understand what your problem is. But if the few times that I've ever swatted him, even though he swatted me back, he usually stops what he's doing. I don't have kids, but I definitely have a cat. So negative reinforcement is like a negative feedback loop. I don't like what he's doing, so I swat him and it stops. Positive feedback is when I reinforce whatever's occurring to keep occurring until the stimulus is removed. So if we have an example of a heater, the temperature falls to 19 degrees Celsius or 67 degrees Fahrenheit. That's cold. We don't like it to be that cold. We can't function that well when it's that cold. The thermostat activates the furnace. We get some heat output. Buddy, you've got to stay in one place. We get some heat output and the room temperature rises. Leo, you can't sit right there. No, buddy, no. So the room temperature rises to 20 degrees, which is 68 degrees Fahrenheit. And now the thermostat shuts off the furnace. And the room cools down again, and then the temperature falls again. Now let's look at it a different way. Typical temperature of an individual is about 98.7 degrees, right? I know a lot of you work in the healthcare field. Is that about correct? 98.7. If your temperature starts going up, let's say, I'm going to call in someone that I can't see their face here. Let's say Christy starts working out. Christy's temperature starts going up. She has thermoreceptors in her body that recognize that her temperature is going up. However, if we get to a certain temperature, body functions may not work very well. And so we have mechanisms such as let me back up. So the thermoreceptors send a signal to our nervous system, our control center, saying the temperature is too high. The skin, and a signal then goes out to our sweat glands in our skin, telling them to secrete water to cool down the body temperature and bring it back down. That's a negative feedback loop. So I'll use some basic questions here. What is the definition of homeostasis?
D.
The ability to maintain relatively internal stable conditions, even though the outside world changes continuously. Correct. Major components involved in these feedback loops. We have an imbalance. Life is always changing, so there's always something that's pushing the limits of our physically tolerant boundaries. There's an imbalance produced by a stimulus in the environment. That change, that imbalance is detected by a receptor. The receptor sends a signal along what's called an afferent pathway. Think of afferent as meaning incoming. We'll talk a lot about this as we go, but afferent means incoming. So the receptor sends a signal into the control center, which is predominantly our nervous system. And the control center determines what it's going to do with that input. Sometimes it may not do anything with that input. But when we're trying to maintain homeostasis, and if we don't bring down the temperature, there are certain systems that are going to stop functioning or slow down in their functioning. An output goes out along an efferent pathway. Think of efferent as meaning an outgoing or an exiting pathway. So afferent, incoming, efferent, outgoing. That effector then does something like the sweat glands contract to release water onto the skin to bring down the temperature. So major components of this feedback loop are a stimulus, a change created. That change, okay, so I'm sorry, let me say this differently. 5 components of a feedback loop. The stimulus that produces this change. Second, that change is detected by a receptor. That receptor sends a signal to the control center, with the control center meaning the third part. The fourth part is then an effector that receives a signal from the control center. The fifth is a response. Are there any questions about this so far? It is 11:09 and I think our class ends at 11:10. Have a wonderful weekend. What are you going to work on between now and next Friday?
The chapter 1 quizzes, chapter 1 quiz, and then the chapter 1 like questions from the book.
You're correct. Work on the smart book assignment first. Get that done first. Work on the practice. You can take maybe one attempt with the quiz, but wait until we finish the chapter 1 in lecture to take the second attempt. Have a wonderful weekend, okay?
All right. Thanks, Mary.
Thank you. You guys too.
Yep. Thank you.
Have a good weekend.
You too.
You
Be safe
guys.
at work.
You
Be safe at work.
I'm sorry, but what
No, go
for
ahead.
next class, what assignments do we have to do
So
or should
work,
work on?
work on the chapter 1 smart book assignment
Okay.
and work on the chapter 1 practice.
Okay, thank you.
You're welcome. Ella and Casey, are you there?